This is Steve Markstrom again. I'm talking about the GW Flow module that simulates the groundwater process in PRMS. Groundwater in PRMS is a calculation of the base flow component of the streamflow hydrograph. That's what it does. If we think about base flow as being an exponential decay, essentially that's the way it's modeled in PRMS. Think about it in terms of this equation here, characteristic depletion equation. If you plot a hydrograph on a semi-log piece of paper and do a separation, what we're interested in, okay, if you look at this equation, T is the time step, that's the value on the x-axis. Q0 is the initial amount of storage. Then this Kr is essentially the groundwater flow coefficient. And if you do this hydrograph separation on semi-log paper, here you can see the groundwater flow separation. In this case, you can see the slope of this line is this value of Kr. To get it into the form we use in PRMS, if you integrate it to get it into an expression in terms of storage, comes out looking like this. We have, for every HRU, we have a groundwater tank, and every time step, that tank has some amount of storage, and the flow out of that tank, which is essentially the amount that that HRU is contributing to base flow to the streams that it's connected to, is described by this right here. So we can compute Q, the base flow, at any given time using this groundwater flow coefficient. You've got the Q at this time step, subtract that Q from the storage at this time step, and you get the storage for the next time step. This is the same system one time step later. So basically what you have to do is the parameter for the GW Flow module is this GW Flow underscore conf, and really what it is, it's this value from this slope in this plot. So of course it's not quite that easy. If you look at this tank, there's going to be something coming into that tank, right? It gets filled up, and if you listen to the soil zone presentation, you'll know there's going to be some inflow from the soil zone. And in fact, this is the equation from the PRMS user's manual. The soil zone is contributing to the groundwater. The subsurface reservoir is cascading groundwater from upslope, and also if there's any storage from depressions. All of those things could contribute water into this tank. Likewise, we've got a feature called the groundwater res sink. This equation is essentially the same as the base flow, but there's a parameter, groundwater sink underscore conf. You set this in the parameter file, and so some portion of the storage can come out as the sink, and this represents gauge underflow or groundwater moving across the basin boundary that's not accounted for any other way in the model. So that's the groundwater sink, and that's it.